Hey everybody, this is Larry. This is day 30th, is it? Oh, what did I click on? Oh, no, that's nothing. Oh yeah, the last day of the Leetcode daily challenge. I've solved everything else, right? Did I not solve that one? The premium? Huh. Did I not click on submit yesterday? Alright, well, let's just click on submit yesterday then, or today. Huh. That's interesting. I mean, I did this video already, so it's a good thing because, that would be a very, I mean, I don't think that counts as a streak, so it's fine. But there we go. Anyway, sorry for the much delayed intro. Let's do day 30th of the September Leetcode Daily Challenge. This is the last problem of the month. We'll be doing it again in October, though I'm going to do a little bit traveling, as I kind of mentioned in a previous video. I'm going to be in Taiwan and Japan at some times. So definitely if you're in those cities, well, I mean, they're countries, not cities, but if you're in cities in those countries, let me know or join the Discord probably, and maybe we'll get some food or something, as I have done in the past. All right, let's take a look at today's problem, 456132 pattern. But yeah, we'll do it on October. So yeah, hit the follow button or whatever. I don't know, whatever people do. And all right. So anyway, given in an array of n integers nums, a 132 pattern is a subsequence of 3 integers num sub I, num sub j, num sub k, such that I is less than j is less than k. So in order, I, k, j. So 1, 2, 3, I guess. All right. Return true if there's a 132 pattern in nums. Otherwise, return false. Okay. I'm just trying to think of, so I mean, this n is 2 times 10 to the 5th. So again, we should not expect to be able to do n squared, because that's just too slow for obvious reasons, right? If it's not obvious, n is too big. Okay. So I think there are a couple of ways we can think about this, maybe. I mean, for these kind of problems, I mean, it's not even like a kind of problem. It's very ad hoc. But I am going to go over my thought process. I don't know how... This actually seems a little bit tricky, possibly. But I think about my thought process and how I kind of attack these problems, because I think maybe that's more interesting. And, you can figure... you can let me know if you have questions. But... because I think this is also one of those problems where if you look at the code, just like yesterday or whatever, like, you may be like, oh yeah, of course, obviously. But then, like... the thought process and getting to the problem, the solution is going to be kind of the key thing here. So there are a couple of things I would think about, right? I think it's called 132, so there are really only 3 ways of attacking this problem, right? For me. And I have to think for each of them. I don't know which one is the right way right now. Or maybe all 3 of them work. I don't know. But it means that, given nums I, j, and k, I'm trying to think whether, we try to see if we have the I or the 1 in the 132, then can we find the 3 and the 2? If we have the J, the 3, can we find the K and the I? Or lastly, if we have the K, can we find the 1 and the 3, right? I think in this particular... maybe that's not true, actually. I mean, I think there is some symmetric thing where maybe you could say only 2 of the cases are unique, because I think technically 132 is the same as 312 in some way, and so you can kind of, there's some symmetry there for sure. So I mean, it's not quite a perfect symmetry, but if you could solve it in 132, or you think the 1 in the 132, you could probably solve it as the 3 in the 132. But maybe I'm wrong on this one, because it's a little bit awkward. The symmetry is a little bit just like, it feels weird, right? So, okay. Oh, so those are the things that I would try to think about if I'm trying to find this pattern, right? Of course, there is also maybe... it may be also be the case where we, and I don't know if this applies to this problem, which is that you may also try to find a pattern such that there's no 1, 3, 2 patterns, right? For example, and I don't think this is the case, but you can also say that like, oh, maybe if it's sorted, then there's no 1, 3, 2, which is true, but it's not the exhaustive set of things that are not 1, 3, 2, right? Because I think like we just have literally the number 3, 1, 2, then there's no 1, 3, 2 pattern, but of course it's also not sorted, right? Just as an example, but these are things that are in my mind as to how I would begin to attack problems, right? Or attack this problem. And let me think about this, right? So let's say just by I don't know, it's just the first thing, because I don't really have an inclination as to which way is the best for this one, but right now, so I'm gonna just almost just try everything, right? I mean, what else am I doing with my life? Right? Yeah, on a Friday night. Actually, I'm kind of hungry. But no, just kidding, by the way. No, so let's say we find a 1, right? What do we need? So that means that we want to find a number that is really big and then a number that's smaller. Or it doesn't have to be really big, but just bigger than this one and then smaller. Conversely, I don't know. That's easy. I think another way to think about it is, I don't know if there's a way to do it with the 1. I think with the 2 is actually also similar in that I don't know if there's any way to do it, because like in a way it should feel like, because you can bisect the problem in a way, because you just have to find numbers that are bigger and the numbers that are smaller to the left, but they have to be in that precise order, right? So like maybe a little bit trickier. Maybe there's a stack-based solution that kind of jumped at that, but I don't know. And then now maybe we'll get to the 3, right? If we have the 3, then I think that is the easiest in a way, because then now to the right side you just have, like on the left side, you just have to get the smallest number, right? And then on the right side you want to get the biggest number that is smaller than this number, right? So I think in that, because so it already makes it easier, because now in a way it's a greedy problem or a greedy solution or attack, right, for the problem, because on the left side you could just do like literally you want the smallest number, because the smallest number has the best chance of being a number there, and then on the right side you want to greedy on the biggest number, because biggest number that's smaller than 3, right? Because then now that has, in a greedy way, I'm probably not describing it right, because greedy problems are always hard to describe because it's kind of obvious, but everything is obvious until it's wrong, and then you're like, well, it's obvious but also wrong, so what do you want, right? So I think that should be right? Yeah, and a couple of ways to kind of maintain this, right? On the right side, yeah, I mean, prefix min, like, I'm not worrying about it. It's just getting the min for a prefix. We can cache if we want. And then on the left side, I think getting the biggest number that is smaller than this number, just from just from remembering this, it's a mono stack problem, right? And I'm not gonna go over mono stack in this particular video too much. I think I did it like maybe a week ago or something like this, or like within the last week, or maybe like 2 weeks ago. I don't know. Let's see. Oh, I guess a week ago at least. Maybe I'm lying. Was it the contest? Maybe there was the contest. So, but the idea behind the monostack is just try to figure out. And here now we divide it into 2 problems, right? That's the beauty of this, is of choosing the 3, is that now we have two separate problems that you can combine in a very easy way. So then now you can focus on attacking them independently in a more straightforward way. And of course, the prefix min one like should be pretty straightforward. It's the minimum of all, the prefix. So, I'm not going to think about it too. Or I know the answer, right? And hopefully you do too. And then the other one is the monostack. So I'm thinking about that one, right? So the biggest number that is smaller than this one. So yeah, let's kind of go for it, right? So what's it called? Right. So then now say and I could do this also, or like another way to do it, to be frank, if you don't want to do it in linear time. I think that's why I'm doing this way, and I'm trying to myself on a Friday evening. But if I just were to do this in a contest, I just want to get it over with. You can also use like a balanced binary search tree, or like a sorted list, or like in C++ like a set, or there are a lot of things you can do, but basically like some sort of binary thing, and that would be log n, and then that'll be n log n, because you're using log n for time. But I'm trying to do it a little bit better, because I think this is something that I've been weak at. I think actually, now that I think about it, that was Q3 of the weekly contest, the last weekly contest. So definitely check that video out if this video isn't good enough for you. And apparently I've probably done it in the past, but I don't know if I do it optimally. So I don't always do it optimally. So I solved the problem, but not always optimally. But yeah, so then now, okay, so while length of stack is greater than 0, and so we want to return the biggest number that's smaller than this number, right? So the ways that I always think about this problem is that, okay, and I'm going to reverse it so that we go left to right in the way I write, is that, okay, let's say we have 1, 2, 3. Well, the biggest number that's smaller than this number, well, it will never be true, right? So we can remove it, and we just get 2, right? So let's say, let's create numbers with more spaces in between, so 5 and 10. So then there are only 3 cases, right? And I don't always need this, because sometimes it comes to me, but today I don't know. So let's say we have a number 4. Well, if we're trying to get the biggest number that's smaller than this number, then maybe I'm wrong on the monostack, to be honest, as well, because then now you pop these off in theory, but right, because for 4 it should be 1, but then let's say you have, and the next number is 11. Oh, I think I'm confusing it. Or I am confusing it, sorry. Because you don't want the next number. I confuse monostack with the next number that's smaller than this number, not the biggest number that is smaller than this number to the entire suffix. So then, okay. Okay, so I'm wrong. It's okay, I think. But yeah, but then now here you can use, so this is, I think we'll defer to, and maybe I'll check out later. Maybe there is a way to do it in linear time. Maybe I'm wrong. But yeah, in Python, I'm going to use a sorted list. Could even use the sorted set, I guess. It doesn't really matter. But in other languages, you can imagine using what was I just saying? Sorry, using a set, a multi-set, an order index, order statistics tree, a balanced binary search tree, a lot of different things in different languages. So yeah, so then now let's just keep track of the suffix answer, right? Well, maybe I don't even need to keep track of this. Let's just do the prefix part first, right? Yeah, so then now prefix, the prefix min is equal to, say, num sub 0. There's only at least one element, okay? right? And then now for x in nums from the first element, and then yeah, this is just the prefix min. And then now we'll go from the right. So here, all right, let's do it from the end, right? So the last number, so okay. Yeah. So this is the first number. So x is the 3, right? The 3 and the 1, 2, 3. So to the right. So if so okay. I guess the way index is equals. So it is bisect left of. Oh, this is a little bit annoying because yeah, I mean you could do it in a couple of ways, I suppose. But I guess I'll okay, fine. Yeah, right. So then this is the next. So this gives us the index of the number that is x or greater. So then index -1 should be the biggest number, right? So yeah. So if this is of course inside the array, so I guess it has to be inside n, but actually this is technically length of sort list. Right, so if this is the case, that means that we found the number. So then we can do SL index -1, and then so this is the 2. This is like 2 is equal to this number, right? And then if 2 is greater than the last number in the prefix, because that's the, I think maybe possibly we're off by 1 because this includes the x. So so then I think we can actually pop this to begin with. Maybe pop it here, because we have to do it for the loop. And then if this is the case, then we can return true. Otherwise, we add x to it, so that when you go from right to left, you can kind of do it. And then return false if none of it is true. I'm going to draw it out. I think I don't do a good job of explaining this. Ooh. Yeah, let's give it a submit. Oh, snap. How did that happen? Maybe I'm just being careless. Yep. Okay. Because this should be the huh. How does that happen? Oh, I'm just being lazy, that's why. I wrote this in a different way than I usually do, so that's why I'm a little bit awkward. I usually write it with a prefix of whatever, but and then now it should be good. And I usually don't do it. That was a very bad choice of sentinel values. Usually don't write it that way. So I think that's the thing with. I mean, I'm not a fan of patterns per se, but that is the thing where, you know, if it's not about a pattern, but if you write things in a different way, sometimes you just kind of forget all the assumptions that you had previously, and this is what happens. So that's a little bit sloppy. Apparently people did it much faster, so maybe there is a linear time way. But yeah, but basically in a way, it's almost like a sweep line kind of way, right? So that you have the prefix, which, like I said, contains the smallest number. So as you move from right to left, you know, your numbers will get bigger as a result, because, you know, that's just the prefix goes. And then to the right, it expands more and more, and that's what the sorted list is for. This is n log n, because this is n loop, O of n loop, and this is a log n, and we have O of n space in a couple of places. I am curious. I mean, the timing is a little bit slow, so I'm definitely, maybe there is a monostack problem, huh? Yeah. Oh no. Seems like a lot of people just. Let's see. Is that the same? Do I notice a use? I guess there is a stack version. Oh, I see. I see. I think maybe I don't know. I have to think about it the next time I saw this file. But yeah. So I don't know. Still a little sloppy, I suppose. Let me know what you think. Let me know how you did. At the end of the day, I don't know. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.